Hi everyone, it's Sorkin. Today we have a problem when we are given a binary tree node, which we need to convert into the single linked list. So for example, in this case, right, tree node has a left child and the right child. So what we need to do is, after converting tree node to the single linked list, as in here, so the right child should point to the next node and the left child should point to the null. So for example, in this case, let's say that the 1 is pointing to 2, 2 is pointing to 3, and the 3 is pointing to 4. It's a right child is pointing to the next node, and the left child should point to the null. So how we're going to solve this problem? We are going to recursively, first we are going to flatten the right subtree, and then we are going to flatten the left subtree, and then we are so how we're going to do that exactly, right? So for example, let's take it step by step. So what we're going to do is, here first we are calling the root right function, right? So basically we are to the flatten, we are passing the right node, and it also recursively calling the next node 6, and in this case 6 will point to what? The left will point to the null, and the right also will point to the null. We are creating one global variable previous which points to the null, so 6 should point to the null, right? So 6 should point to the null here, to the null. So 6 should point to the null because it's the last node. So the next one, then we are going to the next one, right? So we have so we call the we recursively call 6. Now we are going back to the 5, right? We are going to the back to the 5, and we are setting previous node to 6. We are setting previous node to 6, and for the 5, what we do? 5 left is again pointing to the null, and the next one, right, next node, we are pointing to the 6, right? 5 is pointing to the 6, 5 is pointing to the 6 as in here, and we are setting we are setting to 5, right? So previous we are setting to 5. Now we have completed the right node right here. So we have completed the right node here. Now we are going to the left node. Again, we are recursively calling right. So we are calling left, and it will recursively call 4, right? It will recursively call 4 because the first one we are recursively calling right? So after completing the right subtree, now we are going to the left subtree. So left subtree, we are calling here 2, and 2 will call 4, and the 4 in this case, right? Again, right will point to the previous, and the previous in this case we have set 5, right, from the previous step. So we have set to 5. 4 will point to the 5, and the right subtree of the right child of the 4 will point to the 5, and the left will point to the null. So left will point to the null, and the same way, right? So now the next one is 3, right? So we have completed the right here. So now we are going to the left. But now we are going to the left to 3. 3 again will point to 4. Right child will point to the 4, and the left child will point to the null. And so yeah, recursively we are calling, and at the end we have a flattened single linked list. So what's the time and space complexity of this solution? So we are going over our tree only once. So time complexity is of n, and we are not using an extra space. So we are just changing the pointers. Our space complexity is of 1. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.